time period of a simple pendulum. Over there, we saw that this point mass had actually moved in an arc of a circle, but we said that this theta is very small, so eventually this arc almost becomes a straight line. If this is a big circle, if I show you this big circle, you will say that yes, there is a curvature. But if I remove all the things, if I remove all the points and I just show you a small section of this, so this is almost a straight line. If I make it even smaller, then it becomes very difficult, almost impossible to say that this is part of a curve. The kind of a same thing we are used over here when we say the body has been displaced from here to here, so this is almost a straight line. The restoring force is almost toward this point, that is mg sine theta. But otherwise, this is angular SHM. In angular SHM, the bodies which are executing SHM, they are moving along a arc. So how to find the angular SHMs? As we did in rotational mechanics, we had some linear parameters, and to that we had analogous parameters in rotational mechanics. Similarly, over here also, we have some method, we have some steps how to find the time period in the linear SHMs, and we have some analogous steps in rotational, that is in angular SHM, that is how we can find the time period in angular SHM. Let's compare the two. This is over here, I say that is linear parameters, and over here we say angular or rotational parameters. Over here we displace the body by distance y, and over here you displace the body by distance theta. We find the restoring force, over here find the restoring torque. We put F restoring force is equal to mass into acceleration. Over here you put the restoring torque is equal to m, analogous to mass is I, analogous to A is alpha. We have done it time and again in rotational mechanics. If there is some confusion, you wish to revise it, you can revisit those lectures, and once you are thorough with this, you can come over here, or if you wish to continue, you can continue here also. That is not an issue. Torque is y alpha, so over here we prove that is acceleration is proportional to minus y. So acceleration analogous over here is alpha, alpha should be proportional to y, y is theta represented by theta, so it should be minus theta. That is alpha should be proportional to minus theta. That is angular acceleration should be proportional to minus theta. So this means now if acceleration is proportional to minus y, this means SHM. Similarly over here, if alpha is proportional to minus theta, this means SHM. Over here we say t is equal to 2 pi y by a, that is the time period for SHM. Over here we say that is time period of angular SHM is t is equal to 2 pi, instead of y we have theta, and instead of a we have alpha. Let's see how to do it. We take the same example over here. We had taken over here mg and we had done mg sine theta is equal to ma, and from there we had solved it. So now let's find time period using this angular SHM concepts. So the first step is displace the body by theta. So over here we see that it has already been displaced. This is point O from which it has been supported. Second is find torque. Let's find torque about O. Torque of which force? There is only one force over here, that is mg. We will find torque of this only because this tension is passing to the O only, so the torque of tension is going to be equal to 0. We know torque is always of a force about an axis, and torque of a force is force into perpendicular distance between line of force and axis of rotation. So we are finding torque of this force about this axis. So torque of this force is going to be force, that is mg, into perpendicular distance between line of force and axis of rotation. So this is line of force, this is axis of rotation. This length we have taken it as L, so this is going to be L cos theta, and from here to here the component is going to be L sin theta. So torque of this force about this axis is mg into L sin theta, right? So we have done theta, we have displaced the body by angle theta, we have found the torque also. Now we have put torque is equal to I alpha. So this is torque, we put it is equal to I alpha. I, this is a point mass. Moment of inertia of this point mass about this is obviously of a particle is m into distance square. So m into L square, I into alpha is equal to mg into L sin theta. So over here we see that is m and m that can be cancelled. This square and L goes off. So alpha is equal to g by L into sin theta. Once again we say that this theta is very small, So sine theta expansion is, Maclaurin's expansion is sine theta is equal to theta minus theta cube by 3 factorial plus theta raised to 5 by 5 factorial minus theta raised to 7 by 7 factorial and so on. If theta is very small, we can neglect these higher powers, and so this comes out to be, alpha comes out to be G by L into theta. Now we also see that is torque of this force about this axis is trying to rotate the body in this direction, that is clockwise direction, whereas theta has been in this direction, that is anti-clockwise direction. So alpha and theta, that is torque and theta, torque is equal to y alpha, what's the direction of net torque, the same will be direction of net acceleration also. So direction of this angular acceleration, when I say acceleration, this is angular acceleration. So the direction of angular acceleration is in this direction. Theta has been in counterclockwise direction, so they are opposite directed. So we can directly say that is alpha, see this and this is constant. So alpha is proportional to minus theta. So I remove the equality sign, I put this proportionality sign. So alpha is proportional to minus theta. So this means SHM. So this implies T is equal to, so this implies T is equal to 2 pi theta by alpha can be used. T is equal to 2 pi theta by alpha. If you look over here, theta by alpha is equal to L by G. We get the same time period. Obviously we should get the same time period whatsoever method we use, whether you use physics, chemistry or mathematics. If there is a pendulum which is moving like this and it has some time period, it is going to remain same irrespective of what is the methodology or which is the science we are using to find the time period. So time period comes out of the same, T is equal to 2 pi under root L by G. Seconds pendulum has a time period of 2 seconds, length is 99.3 centimeter.